In the month of March 2019, the Arctic was at least 20 degrees hotter than it should be. Under that massive heat, sea ice is at a record low. Unprecedented Arctic warming is distorting weather in the whole Northern Hemisphere where the majority of humans live. Extreme weather has brought unhappiness, vast damage, and death. In this new climate age, the idea of progress seems to be replaced by constant efforts to recover. In the past 3 months, I brought you the science of climate change direct from specialists publishing top papers. To draw it together, we need a generalist with climate expertise. We need Paul Beckwith. Paul has 2 master's degrees. He often teaches climate science at the University of Ottawa, but his tireless effort to teach extends to the Internet. On YouTube, Paul Beckwith is by far the biggest teacher of climate science to the world via YouTube. Paul Beckwith, welcome back to Radio Ecoshock.
Hello, Alex.
All right, so Radio Ecoshock has listeners all over the world, as you know, so I try to keep a global perspective. But right now we need to talk about the second largest country in the world, Canada. After 10 years of being shut out with talking with the federal government scientists, that was during the Harper regime, today I finally talked with the climate scientist Nathan Gillette from Environment Canada, and he told us the rate of warming in Canada was double the world average. What is your reaction, Paul?
Well, Canada is a northern country, and we know that the further north you go, the quicker the warming is. So often people say that the Arctic is warming at double the rate, but that depends really on how you define the Arctic. As you go further and further north into the Arctic, the rate of warming is 3 times the global average, 4 times, 5 times, and so on. So I think the report that came out by Environment Canada about what's happening in Canada, it said overall I think the average was 2 times for Canada, but northern Canada is definitely 3 times or even quicker warming. This is a global pattern that we're seeing. Also, as you go up in elevation in mountains, the warming is also doubled or tripled over the global average, and people don't talk about that so much either.
And you know, many of our listeners worry that if Arctic ice disappears during the summer, that could change weather and climate for the world. I know you have been talking about that for years, literally. Is that worry legitimate?
Yes, the basic physics of how things heat up and how there's a phase change, like from a gas to a liquid to a solid, for example. So, I've often said that the ice acts as a refrigerator. As long as there's ice in the Arctic, then the surface temperature while that ice is melting is about the freezing point. It's close to, 0 or slightly below, depending on the amount of salt in the ice and so on. But, so the ice, it keeps the Arctic cool, and when we lose the sea ice, then of course we've got this open ocean, and it's going to warm tremendously fast compared to what happened when there was ice there. So we're seeing this. This is a big, huge concern for the globe because basically when there's no sea ice for the first time, and that could happen very, very soon. For some people are even talking about this year, but it's hard to predict any given year. But then the Arctic temperatures will literally skyrocket, and the jet streams will become completely unrecognizable. We're seeing lots of problems with the jet streams being stuck. For example, this big, huge trough over North America this last winter is one thing that is resulting from a stuck jet stream.
Well, Dr. Gillette is the coordinating author for some part of the upcoming 6th report of the Intergovernmental Panel on Climate Change. He helps run Canada's climate models. And with you in mind, Paul, I asked Gillette when the sea ice might be gone in summer, the so-called Blue Ocean event. He suggested that might come around the year 2050. Do you agree with that?
No, I don't. And in fact, most sort of, I'll say in quotes, mainstream scientific views would say that number is closer to 2040 now. But if you look at the trends of the sea ice extent and the area and the volume, those trends are all sharply downwards, and those trends would seem to indicate that this event with no sea ice, the first Blue Ocean event, might happen within the next 4 or 5 years if you just follow the data. Of course, if there's some sort of feedbacks and some other things happening, the climate system is always full of surprises, but the vast majority of these surprises are faster than expected. almost never slower than expected. So, if expected by the most scientists is 2040, faster than expected is going to be, much, much sooner than that. And this last winter, the ice did not form that thickly. It was not strong, it's not thick. And the spring, the last few months we've had tremendously huge temperature anomalies. The Arctic's been super warm, and the ice is melting very, very quickly. In fact, it's about a month ahead of the normal melt, at least a month, maybe a month and a half ahead of the normal melt. If you look at I highly recommend people just Google Arctic sea ice graphs and look at some of the data. It's updated every day, and you can see it looks like the ice is plunging off a cliff in terms of all of the measurements of how much there is.
We have an important new paper published April 8th by scientists in Alaska and Denmark. The title is Key Indicators of Arctic Climate Change 1971 to 2017. Lead author Jason Bach said, quote, "The Arctic system is trending away from its 20th century state and into an unprecedented state, with implications not only within but beyond the Arctic." Have you looked at that paper, Paul?
Yes, it's an excellent paper. And what's nice is that a lot of these papers that are coming out now are in open journals, so they're not behind paywalls. So anybody can go, and Google the title and find the original paper and have a look at it. And, I highly recommend that people do that. I mean, and not worry too much about all of the scientific technical details, but look at the abstract, which basically is the gist of the paper, and look at some of the figures. And when there's significant papers, I try to usually do a video and try to explain it in a sort of layman's terms as to what significance it has. So, yeah, I mean, the Arctic is completely changing, very, very rapidly. It's going to a much, much warmer place. A lot of the air from the Arctic is spilling out of the Arctic and going very, very far south, which it's been continuing to do over North America at the moment. So, all this cold air that comes south means that the Arctic is getting much warmer. That cold air is being replaced by warm, humid air. So it's raining a lot more in the Arctic. And, of course, that rain just cuts through the snow and it melts the permafrost and all the rest of it.
Paul, what has the winter been like where you live in Ottawa, Canada?
We've had a very, very long winter. We had the first significant snowfall in early to mid-November. And we've had recent snowfalls, in April, significant amounts of snows. And a bit south of us in the U.S., they had this so-called bomb cyclone and, many, many feet of snow. And that's also happening in April, another bomb cyclone with many, many feet of snow expected. And, of course, that's led to tremendous flooding in the Midwest. So, we've had a very cold spring, and it's sort of continuing.
Yeah, I delayed my planting of garden here in British Columbia by 2 weeks because it was just too cold. The warmth hasn't come yet. And this brings up an interesting point because the public is so focused on global warming, it's pretty hard to convince people that a depressing cold winter could also be influenced by climate change. Do you think that this winter has had some climate drivers? I
think at this stage in the climate and weather situation, rapid and abrupt changes, you can't really escape them now. I mean, this winter, the jet streams have had this very, very large trough, which has extended down over lots of North America, deep down into the U.S. And it's been a persistent pattern over North America this winter, and it's pretty much continuing into spring, although there are cases where it kind of rotates around and we get warmer weather for a bit, but then it comes back. So this is the sort of case that's happening with these bomb cyclones, for example. One of the things that I talked about in the past, really thinking about, what will happen when there's a blue ocean event, because, people are focused on, okay, we're losing sea ice, we'll get a blue ocean, but then what next? Like, how long will it last? What will be the duration in subsequent years? Will we, if we have an open ocean for a week or two, or maybe the month of September in a few years, the first event, then what's happening within maybe a couple of years, it's open ocean for 2 or 3 months of the year, for August, September, October, and within a few more years, then tack another month on either side. So open ocean, July, August, September, October, November. And then, of course, with the feedbacks, you can, I think that we'll go to this situation within about a decade of the first blue ocean event. And then what's going to happen? Well, what happens with the jet streams? I mean, the jet streams are centered over the cold in the Arctic, right? They're dependent on where all the cold is and also on the rotation of the Earth and things like that. And when there's sea ice and snow cover, then the center of cold is near the North Pole, offset a bit towards Greenland, because Greenland extends quite far south, with the snow and ice. But then when there's no sea ice and there's much, much less snow cover on the land, the center of cold is clearly Greenland. And the center of Greenland is at 73 degrees north latitude, which is offset from the North Pole by 17 degrees. So does this mean that the jet streams will start rotating about the center of Greenland when there's no sea ice for long periods of time? And if so, this means that they will extend much further down into North America, bringing a lot of cold that used to be up in the Arctic into North America, right? So if they're centered in a different location, then we could be the last sort of bastion on the planet, the global warming hole, if you like, the area where there's lots of cold air coming down from the Arctic, for example. So, are we starting to see this winter and in maybe the last few winters? It's an open question.
You're listening to Ecoshock Radio for the world.
I'm Alex Smith. Get it all at our website, ecoshock.org. You are tuned to Radio Ecoshock. I'm Alex Smith. With us is Canadian climate scientist Paul Beckwith. You mentioned the flooding in the Midwest of the U.S., right in key food production areas, and I think that was a major event with long-lasting consequences. The mainstream media has forgotten about this story already. Tell us a little bit more about that, Paul.
Yes, so because the trough of the jet stream has extended far into the U.S. for most of this winter, it meant that there were lots of these storms coming through, especially at the transition point between the cold, dry air that's in the trough of the jet stream and then the warmer, humid air that's outside the trough. So we've had these streams of storms coming through, dumping huge amounts of precipitation and, some snowfalls of 4 or 5 feet with these bomb cyclone type things. So we've had a very brutal, tough winter. And of course, then a lot of the snow, when it's melted, it's just the ground is being frozen still. So the water can't infiltrate into the ground. So it just runs on the surface. We've had this huge widespread flooding. And the water has just been sitting there. And, of course, there's lots of pollutants and things that are carried in the water from the cities and things. So the soil gets saturated. You can't plant, basically. I mean, what about even now, the ground is just too soggy now, and there's lots of water still lying there. So how can farmers plant? So this is really going to affect the food production in the U.S. But it's worse because of the tariffs and the trade battles between Trump and China, basically. A lot of the farmers, it wasn't profitable for them to sell all their grain, so they stored a lot more this last year than they would normally have stored. And, a lot of these grain elevators that store the seeds, when they're flooded, the grain will then expand, and it's kind of exploded the big elevator, so they've collapsed. Of course, all that food, all that stored grain has been lost, and you can't plant, so it's just asking for trouble. I think there's a good chance of food price spike, later on, end of summer, early fall, when this trickles through the system. Yeah, it's not a good situation at all.
This is Radio Ecoshock. I'm Alex Smith with my guest, Canadian climate scientist Paul Beckwith. Okay, this is a perfect time for me to tell listeners about brand new science. It's still awaiting publication, and it announces a new phenomenon in the world, simultaneous heat waves across the planet. Professor Martha Vogel, a climate researcher at ETH Zurich, just presented the findings at a European Geosciences Union press conference in Vienna in the first week of April. And studying heat waves from 1958 to 2018, they discovered that only since 2010 has a modern planet Earth experienced multiple extreme heat waves at the same time. For example, extreme heat in the Mediterranean might also strike in the Arctic and Russia or North America at the same time. So transcontinental heat, that has terrible implications for food production and a lot more, just as you say, Paul.
Yes, and of course we can't forget the oceans. I mean, the oceans have been absorbing 93% or something of the heat on the planet, for years and years and years. So when they release this heat, this is a big factor in these global heat waves. I mean, mostly these global heat waves are considered, in the past, they're mostly well within continents, right? They're not near coastlines. I mean, the water is always a moderating factor because it takes a lot more energy to heat up and cool down water because of its high thermal heat capacity. But now, when the oceans on coastlines, for example, in the Middle East are 34, 35 degrees Celsius temperatures, then we get at least those temperatures on the coastlines with almost 100% humidity, and this is a wet bulb temperature where humans cannot work outside. They can't basically survive these conditions because the body's not able to sweat. I mean, we are trying to get more heat-resistant and heat-tolerant crops, for example, right? So science is trying to keep up, but the changes are so rapid, it's very difficult to do that. Most crops, as we know, thrive within a narrow tolerance range in terms of temperature, assuming there's sufficient precipitation.
And a lot of that discussion of ocean heat is in a new report from the World Meteorological Organization, and you've done 2 new YouTube videos about that report. According to the WMO, in 2018, the heat content of the upper levels of the ocean were the highest ever recorded. Talk to us about that importance of ocean heat content and the current trends. If you can expand on that a bit, please.
Yes, of course, the distribution of heat on the planet is key. And, we all know that the equator is warm and the poles are colder. And the heat moves from the equator to the poles via the air currents, in the atmosphere and also in the ocean. The ocean currents are moving much slower, of course, but the ability to hold heat is much greater in the oceans. But, when you work out all the numbers, roughly 1/3 of the heat goes from the equator to the poles via oceans and currents, and 2/3 via the atmosphere. For example, in the Arctic, because the Arctic is becoming a much darker place, it's absorbing more sunlight. It's heating because of this additional absorption, and therefore it lowers the temperature gradient to the equator, so there's less, you'd think that there'd be less flow of heat from the equator up to the Arctic and more going towards Antarctica, for example. So you have to try to think of the whole climate as a system of all of these interconnected parts. Now, the warming ocean, of course, is a huge problem because warmer water floats on top of colder water, so the ocean becomes more layered or more stratified, if you like. There's less water moving in the vertical direction, and we need water upwelling because the nutrients that are needed for plant growth, for phytoplankton growth, which is the base of the food chain in the ocean, they need these upwelling nutrients. So as the ocean becomes more stratified, it has a huge impact on the ability of plankton to grow. And, and the ocean currents are, of course, changing because of the greatly warming Arctic, and, the thermohaline circulation system is slowing down. So, we're changing. The way heat is transferred on the planet seems to be completely changing, along with everything else, from rapid climate change.
People do get confused about the difference between ocean heat absorption, which is 93%, as you say, to greenhouse gas absorption, like carbon dioxide going into the sea, which is about 25% of our emissions. And I think we have to make that one clear. But look, Paul, if 93% of our excess heat is going into the ocean, that means only 7% is causing some of the disruption we are feeling now. And if the ocean takes less greenhouse gases, as scientists predict, then there will be more greenhouse gases remaining in our atmosphere. And if that's true, we have to cut off fossil fuels and other greenhouse sources pretty well immediately. And it seems strange to say, but our industrial culture may depend on ocean chemistry and ocean physics. Do you think that's true?
Yes, I think so. The oceans, they cover over 70% of the surface area of the planet, right? We only live on, the other 30%. I've been saying we're in a climate emergency for years, and we need to slash fossil fuel emissions, of course, but we also need to remove CO2 from the atmosphere, and people are talking about that a lot more, and also, look at solar radiation management ways to cool the Arctic, for example, so that we don't lose all the sea ice and snow cover and expose Greenland to huge melting. And a lot of these techniques, I think, can be done much more efficiently in the ocean. The ocean used to be teeming with life, and that's no longer the case. So, we should be changing our frame of reference to using terms like climate restoration. How do we restore the climate so that it's more like the stable climate that we had before, that we're quickly leaving? And, the oceans can be a huge key to this, I think. If we could restore teeming life in the ocean, think of all the carbon that would be encapsulated in this teeming life, right? Which is, would be carbon in the life as opposed to carbon in the atmosphere and in the oceans, making the oceans acidic. So, stimulating phytoplankton growth, for example, would capture enormous amounts of carbon. We'd have life proliferating all the way up the food chain if we did that with phytoplankton.
You are tuned to Radio Ecoshock. I'm Alex Smith. With us is Canadian climate scientist Paul Beckwith. So, Paul, you say sea ice may be in a critical slowing down of a phase state before a collapse. Where do you get that theory? Well, if you look at some of the papers that have been published, some of our knowledge on abrupt transitions or phase changes or state changes, often what you see is, it's really difficult. We don't have a good way of predicting, when exactly a tipping point will be reached, for example, but we can look at situations where things have tipped, and often the frequency of the changes, if something is trending, say, upwards linearly, there'll be variations and fluctuations, and these fluctuations in the sort of level can be very fast, and then if you average everything out, you get a nice linear increase. Well, the frequency of which these fluctuations occur, that can often slow down. That often does slow down before the system sort of tips into a different state. If the frequency is slowing down, it means that the amplitude of the gyrations can increase. So there will be more variability of these gyrations. So if you look at the sea ice decline, then you can see that there's some quite large variability in what the sea ice is doing from year to year. And, I'm just wondering if that's sort of occurring because we're going to get this massive, change all of a sudden. And I think it's very possible. Getting back to the sea ice, I really encourage people to look at some of the graphs of what the sea ice is doing right now. It's no surprise with an Arctic 20, 30 degrees Celsius warmer than normal in some places for months on end, that the sea ice is rapidly vanishing. In a BBC article about that World Meteorological Report for 2018 that we talked about, Australian climate scientist and Professor Samantha Hepburn said, "We know that if the current trajectory for greenhouse gas concentrations continues, temperatures may increase by 3 to 5 degrees C compared to pre-industrial levels by the end of the century." Okay, so listeners, as you know, that is just utter disaster. Paul, do we know what level of CO2 in the atmosphere would result in 5 degrees C of warming?
We would need to accurately know the climate sensitivity. So for a doubling of CO2, it's believed that the climate sensitivity change would be anywhere from 1.5 to about 5 degrees Celsius. So the mid-level of that is about 3.5 degrees Celsius. Now, that's based relative to pre-industrial when the CO2 level was 280 parts per million. So doubling that would be 560 parts per million, and we're about 410 now, which is about 150 parts per million shy. At the moment, we're increasing about 3 parts per million per year, which would take us about 50 years. But then that doesn't consider, it's not just the CO2 level that's important, it's the CO2 equivalent, if you like. So right now we're about 410 parts per million CO2, and the CO2 equivalent is about 490. So, that's when you include things like methane and these other things. So if you just do if you assume a linear increase, which it won't be, right? It's always faster than expected. But if you start somewhere and assume the rise per year, you can kind of figure out, what year things would happen. But then that would assume that there's no massive tipping points, and we know that the Arctic sea ice is on its way out, and that will represent a huge tipping point, an acceleration of warming in the Arctic, disruption of the jet streams, disruption of everything else. It also assumes that there's no huge, methane burst, of course. Peter Wadhams has done papers about a 50 gigaton burst over, say, 5 gigatons a year over a decade, or a burst all at once. And that would cause a very, very rapid warming, initially of the region where it came out, which would probably be up in the Arctic, and how that would affect the planet. So it's really, 5 degrees it would be catastrophic, of course, for civilization. The IPCC, they talk about an increase of 2 or 3 or 4 or 5 degrees, but they very rarely have talked about the implications. And look, have we had a degree of warming? That's what most people will tell you. We've had 1 degree of warming, but then that's usually relative to the turn of the 1880 to 1910 sort of average or something. But if you bring it back to a baseline of 1750, which is when we first started talking about, about the Paris, those targets of 1.5 or 2 degrees should be, originally they were all referred to the 1750 baseline. And for some reason that baseline keeps shifting closer to the present to make it seem like the warming has been lower than it has actually been, right? So if you take our present situation relative to 1750, we're closer to 1.5 degrees already. So, with that type of temperature rise, look at all of the worldwide disruption that we're seeing already, right? So, we have to do everything we can to avoid getting anywhere near those numbers, 3 to 5 degrees Celsius.
Well, this brings up another really startling paper. I had a recent interview with the lead author, Tapio Schneider from NASA, and he told us that somewhere starting around 1,200 parts per million, we don't know for sure, but somewhere around there, stratocumulus clouds cannot form, and they are a major shade for the Earth. And that event, and it would be an event, adds another 8 to 14 degrees C of warming. So that's game over for humans and much of life. And I just know how we think. Humans will think that at 800 parts per million, for example, they still have another 400 parts per million margin before hitting that final brick wall. But that fails to realize, just as you say, that as the world warms, the contribution from natural processes increases as well, and most of that is irreversible. So do we know how much of a buffer we need to leave for things like permafrost thawing or dying rainforests?
I don't think there's any buffer for us. We're undergoing these enormous changes around the planet, and it seems to be taking forever for people to recognize that, we're being affected every day. Every week around the planet, there's these really crazy extreme weather events because the climate has shifted. And it's just, when will the pain be large enough for a large enough number of people to actually have governments and actually say, okay, we're in an emergency situation, acknowledge the reality of how bad the situation is and how quickly we're going, it's worsening, and then take strong action at, these three-legged barstool things that I've been talking about. I mean, there is a lot more talk now about carbon dioxide removal, being absolutely required to bring down CO2 levels to try to stabilize the climate. I think a real turning point in human understanding and view on climate change, I guess, might be when there's no Arctic sea ice left. Like this massive flooding in the U.S., people are still trying to attribute these events to sort of just weather and something natural, and, we can't do anything about weather, and, it's nothing to do with climate change. like it's unbelievable how entrenched these views are with major political parties.
You did a YouTube video on a major blockbuster study published by NPNAS October 14, 2018, titled Trajectories of the Earth System in the Anthropocene, and I interviewed the lead author, Will Stephan, here on Radio Ecoshock, and they, in that study, expected the average global temperature to settle between 4 and 5 degrees C hotter than pre-industrial, even if the Paris Climate Accords are carried out, which is not happening. And sea levels can go up 10 to 60 meters, which is 33 to 197 feet, they said. Doesn't that mean that even our best climate plan takes us right to disaster, not just for this civilization, but towards mass extinction? And that's our plan?
Yeah, it's very difficult to understand how we actually got ourselves into this horrible situation. And, we always, as humans, we always try to figure out a way to get out of a terrible situation, right? But we're certainly not. We're doing nowhere near enough, and there's still all of this denialism. And as far as that study goes with the clouds, the effect of clouds on the climate is one of the most difficult things for scientists to model and understand. For one thing, the altitude of the clouds has a huge impact. So these so that just means layered cumulus clouds. These are low-level clouds, basically, and they block a lot of the incoming sunlight, so they keep the surface of the Earth cooler. So that study where, at 1,200 parts per million, if these clouds can no longer form, then all that sunlight can hit the Earth. It won't be shielded out. Meanwhile, the high-level clouds, the cirrus clouds, the highest, wispy, thin, those clouds that are very high up, those clouds actually trap some of the infrared radiation, so they actually have a warming effect. When there's more of these high-altitude clouds, the planet will actually be warmer. So one of the ideas to have more radiation escape the Earth would be if there was a way to thin these clouds. But this study is talking about the good clouds being not able to form, and I don't think it really mentions too much. It wasn't looking at really what was going on with the higher clouds, if anything. We're in a terrible situation. We're in an emergency situation. But I think we are coming closer to people recognizing, around the planet that, yes, we're in a terrible situation. But the problem is that the power structures, they have far too much influence and control on actions at high levels. And, they're not acting in the interest of the public at all, with continuing to subsidize fossil fuels and denying climate change and, making very select few number of people extremely wealthy that are in the industries that are the root cause of the emissions into the atmosphere of greenhouse gases.
Yeah, you were, I think, sort of a leader in calling for a planetary emergency, and now there are groups calling for that. For example, climatemobilization.org is calling for that. Do you see that call for immediate large-scale action growing? And, for example, were there school strikes where you live in Ottawa or in nearby Quebec?
Yes, there's groups called Extinction Rebellion, which are growing in leaps and bounds across the planet, lots of different places. There's the students, right? Students, starting with
with Greta Thunberg.
With Greta Thunberg, yes, in Sweden, and her, she did it by herself for many months. She would just, sit outside Parliament on Fridays and not go to school, strike come. I mean, I think, I don't know, maybe it started all week, and then she moved it just to Fridays. I mean, she's a bright kid, and she could probably learn everything and not go to classes at all. But, and then that was involved 1.4 million people around the world recently, and there was a big march in Ottawa onto Parliament Hill, and I believe it was March 15th or March 16th or something. So I joined, and there was a good sized number of people. It was, I estimate about 1,000 people in Ottawa were at this event. And this was a worldwide thing, and it's also continuing. So, there's more and more people recognizing that we're in a lot of trouble with climate change, but there's still this inertia of the old system. There hasn't been a tipping point in human action, I guess, to carry us where we need to be. I mean, when we see government getting rid of their, like even the Canadian government, with Trudeau and their climate, the carbon taxes, right? I mean, they bring in the carbon. It's sort of deja vu to the Green Plan years ago, which cost Stephen Dion his job, right? The green shift or whatever, they called it the Green Plan. Like, he brought in the carbon price, and then they lost the election, and they said, well, it was because he brought in the carbon price. No, it was the price of oil was $140 a barrel, and the Liberals were unpopular anyway then, and, but as long as these governments are funding fossil fuels to the tune of billions and trillions of dollars, it sort of makes a mockery of everything else they say and try to do. Like, they're just not being honest about the problem.
Yeah, for sure. I mean, international listeners may not know that Prime Minister Justin Trudeau, when he was faced with the fact that private enterprise, the oil companies and gas companies, didn't want to build an extra pipeline to Vancouver due to public protests. They didn't want all the tankers on the coast, for one thing, didn't want the climate change for another. He just decided, the government will buy this pipeline project for, I think it was $4 billion, and the government will build it so that we can get that dirty tar sands oil out of Alberta and into the world market so we can burn even more carbon. So don't talk to me about a green plan and how green you are when you're doing that kind of stuff. And it's happening all over the world. We're seeing what Trump's doing. I don't even want to go there. It's terrible. So I'd like to focus a little bit more as we wrap up here on you, Paul Beckwith. You get a lot of visitors to your blog at paulbeckwith.net. You currently have over 15,000 subscribers for your 538 videos on YouTube. And as of April 11th, your channel had 3,257,000 views, so millions of views for this work. How did you end up becoming an electronic climate science teacher to the world?
I don't know. I mean, you don't really plan a lot of these things. I think what happened is, at university, I started teaching a climatology course, a second-year climatology course, and just loved it. So I taught it again, and then I started teaching other geography courses, like geographical approaches to environmental issues, and then I designed and taught an oceanography course, and I just taught more and more courses, and then started to create these, did a blog for a while, and then started to do these videos, and the videos started to get more and more viewers, and it just kind of took off from there. I mean, I was able to reach a lot more people from videos, and it's a different way of teaching as opposed to being a lecturer in a classroom to, a big class and to doing it in front of a camera and sending it out to the world. So, yeah, it's just sort of carried from there, and it's all being sort of driven, I guess, by, a passion to get information out to people on, what was really happening with climate change. I found that the scientific community, really failed miserably in getting the information from their papers. We're a world of specialists, I guess, each doing our own specialized thing, and it seemed to me that there was a huge void of people who could take all of the research and all of, sort of form a big picture of, where things are going and what's happening, what happened in the past, where are we now, what can we expect in the future? So, momentum just sort of built up, and I started doing it more and more. And, I must say, it's not the easiest thing to do to be facing climate change, rapid and abrupt climate change, right? It can be a very, it's a very sort of negative thing. I mean, we're trashing our planet, and, a lot of people just want to turn away and pretend it's not happening until there's direct effects on people. And now there's more and more direct effects on people. It's difficult to always be the bearer of bad news to people. So, I've often struggled with, am I making an impact? Do I really want to continue this? Do I want to phase it back? Do I want to maybe focus a bit more on trying to look at so-called solutions? Do I even think that there are any possible solutions? Because there's a lot of doom and gloom right out there. There's a lot of people that go from, climate change isn't a problem to, we can't do anything. It's finished. It's over. Just enjoy your life sort of thing, right? And, it's not all or nothing, right? I mean, I think we absolutely have to try to do things to ensure that we can, survive on this planet. And, we don't know what the final result will ever be. But certainly the political situation has gone from bad to terrible, depending on what country you're in. And, even in Canada, we can look at the U.S. and say, well, I'm glad we don't live in the U.S. We don't have a climate denier leading government who's chopping all of the organizations of science that want to study the problem and so on. But we have a guy who says, climate's really serious and that, and he goes and he buys pipelines and stuff. So it's a very difficult, area to be in. And, I don't have all the answers. I don't have, all the solutions. But, I like to talk about what I see happening.
Well, it's the same for me. In radio, I find it hard, sometimes depressing. Other times I just find amazing science. I love to learn how the world works, and I know you do too. But maybe that's why we need Shackleton the cat in your videos to just touch on something a little bit safe before we head into those graphs of doom that you present. We're going to have to we're going to have to call it for this week with our guest and climate scientist Paul H. Beckwith, and I will load up my blog with links to all the papers and videos that we've talked about in this program. You can find that in my weekly show blog, published every Wednesday at ecoshock.org. Meantime, surf over to paulbeckwith.net to get the latest climate science explained and look for his channel on YouTube. It's easy to find. Please support Paul in his unique work to spread the word over the electronic world. It was great to talk with you again, Paul.
Thank you, Alex.
Be sure to visit my weekly show blog at ecoshock.org. I post links to all the science papers, popular articles, and videos you want to follow up. And thank you for listening. Let's meet again next week.